In the previous lesson, we have learned hybridization state of carbon in ethane. In this lesson, we are going to learn hybridization state of carbon in ethene. So let's begin. Hybridization state of carbon in ethene. Molecular formula of ethene is this, and structure formula of ethene is carbon-carbon double bond, this carbon with 2 hydrogen atoms, this carbon as well with 2 hydrogen atoms. In ethene, carbon atoms are sp2 hybridized. Let us consider electronic configuration of carbon at the excited state. Outermost shell electronic configuration: 2s1, 2px1, 2py1 and 2pz1. These carbon atoms are sp2 hybridized. That is, here sp2 hybridization takes place. That means sp2, 1s and 2p orbitals. Total 3 orbitals take place in hybridization, and after hybridization, total 3 orbitals are formed. 3 hybrid orbitals. Those are named as sp2, sp2 and sp2 orbitals. Here we see one p orbital remains unhybridized. That can be shown in this way: dumbbell shaped p orbital, pz orbital. Here this is pz, which remains unhybridized. This is orbital structure of carbon. Here let us draw orbital structure of carbon. sp2 hybrid orbital, and these are sp2 hybrid orbitals. Another carbon, sp2 hybrid orbitals. These are sp2 hybrid orbitals. With this carbon, there are 2 hydrogen atoms. S orbital of hydrogen overlaps sp3 hybrid orbital of this carbon. Similarly, s orbital of hydrogen overlaps sp3 hybrid orbital of this carbon. In this way, carbon-hydrogen bonds are formed. With this carbon, s orbital of hydrogen, here s orbital of hydrogen. S orbital is spherical in shape. So, with this carbon, there are 2 hydrogen atoms with sigma bonds. These bonds are sigma bonds. And another bond which is formed by head-to-head overlap of sp2 orbitals of this carbon and this carbon. That is, sp2 hybrid orbital of this carbon overlaps sp2 hybrid orbital of this carbon. As a result, carbon-carbon one bond is formed, which is sigma bond. We know sigma bond is formed through head-to-head overlap of s and hybrid orbitals. So this carbon-carbon bond is a kind of sigma bond, because this bond is formed through head-to-head overlap of hybrid orbitals. So we got carbon-carbon one bond that is sigma bond. Again, we know that each carbon atom contains unhybridized orbital, which is pz, unhybridized orbital pz. Now, this unhybridized pz orbital overlaps unhybridized pz orbital of this carbon, like this. This is carbon, unhybridized pz orbital. This is carbon, unhybridized pz orbital. In this way, pz orbital overlap. As a result, another bond is formed, which is known as pi bond. Here, in this molecule, this pi bond formation can be showed in this way: pz orbital, pz orbital attraction force, or minimum overlap. The bond, which is formed by sidewise overlap between two unhybridized orbital, is called pi bond. In case of pi bond formation, overlap is minimum. That is why pi bond is a kind of weaker bond. But when sigma bond is formed through head-to-head overlap of hybrid orbitals, then amount of overlap becomes maximum. That is why sigma bond becomes stronger. So pi bond is weaker and sigma bond is stronger. Sigma bond is formed through head-to-head overlap of s and hybrid orbitals, but pi bond is formed by sidewise overlap of unhybridized p orbitals. Sigma bond is stronger because of the maximum overlap. Pi bond is weaker because of the minimum overlap of orbitals. So this is complete orbital structure of ethane, in which one carbon-carbon sigma bond, one carbon-carbon pi bond. In this carbon, two carbon-hydrogen sigma bonds. In this carbon, two carbon-hydrogen sigma bonds. This is all about hybridization state of carbon in ethene. No more today. Thank you very much.